Hello my dear student, welcome to exam prep tool. If you are preparing for GATE CSE or GATE DA, this is the correct place. 300 questions, 300 quality questions I am going to explain here. Mostly in GATE examinations, questions will come from these 300 questions only. Most of my students every year used to say this only to me, sir, questions came from your notes. So I'm strongly saying to you, don't miss one question also out of these 300. It will really helpful to you in the examination. You will get a lot of advantage. First of all, myself, I am Subbarao Gunta. My students used to call me Reddy sir. I have 14 years of teaching experience. I guided more than 25 lakh students. Right? And one more thing I want to say to you, I am from IIT Bombay, right? In computer science department. I am the GATE top ranker. All my team members are IITians. 300 quality questions we made. Don't miss one also. Definitely most of the things will come in the GATE examination. And while seeing this lecture at anywhere, if you find out any doubt, this is our WhatsApp number, right? Message us. This is our WhatsApp number. Please message us, right? Your doubt will be resolved by our team members. Hope this class will be really useful to you. Go ahead. Everyone listen. Yeah. So to this, how many colors needed? Edge coloring. I am very sure you are okay with the vertex coloring, you know, right? Just we are discussing about edge coloring here. You are fine with the vertex coloring, right? Just I didn't explain anything in the class about the edge coloring. So let's discuss a little bit about it. So can you help me now? What is the edge coloring for this? What is the edge coloring for this? Yeah, good evening. Good evening, everyone. So no two adjacent persons. So, right, two edges having common vertex. Two edges having common vertex. Then those two edges are called as adjacent edges. No two adjacent people should contain same color. No two adjacent edges should contain same color. Can you help in how many colors? I think here, because of this person adjacent, they cannot contain same color. So C1 here, C2 here. Two people are adjacent because common vertex. Vertex 1 is common. They should have different color. Right? They should have different color. Okay, fine. Next one. I think this one and this one adjacent. Vertex 2 is adjacent to this edge also. Because of it, the C2, I can give C1. Now, vertex 3 is adjacent to this also. Already it is the C1. I cannot give C1 here. I can give C2. So, can you help in how many colors here? How many colors here? Edge chromatic number. How much? Edge chromatic number. How much? 2. Edge chromatic number is 2. 2 colors. Right? Everyone know. So because the first time we are doing, right? Yesterday at a time complex problem we tried. We confused a little bit. Yesterday at a time complex problem we tried. We troubled a little bit. So let's explain a little bit. Some more details. Let's go one more problem. Yeah, can you try how many colors for this? Edge coloring required. How many colors for these two diagrams? How many colors for this diagram? So let me give the numbers also. It is a G1 graph. It is a G2 graph. It is a G3 graph. It is a G4 graph. It is a G4 graph. Yeah, try one by one. What is the edge coloring of each and every one? What is the edge coloring of each and every one? Complete one time, then we will go to our actual problem. 2, let me try. Let me try for G2. Let me try for G2. I think it is the C1 color. It is the C2. It is the C1. It is the C2. It is the C1. It is the C2. I think this is also 2 colors. G2 also 2. Let's go to G3. Let's go to G3. It is the C1 color. It is the C2 color. It is the C1 color. It is the C2 color. But what about this one? I think because of C, this cycle is odd cycle. Odd cycle. I think 3 required. Odd cycle 3 required. Even cycle 2 enough. Odd cycle 3 required. It is the C1. It is the C2. It is the C1 I cannot keep, C2 I cannot keep, C3. Odd cycle 3. Odd cycle 3, even cycle 2. Right? G3, G4, both are odd cycle. Both are odd cycle. Both are odd cycle. Both are odd cycle. So I think from this let me write now. Edge chromatic number for Cn. Edge chromatic number for Cn, right? Cn where n is greater than or equal to 3. Edge chromatic number for the Cn means cycle graph with n vertices, where n is greater than or equal to 3. Answer is going to be 2 if n is even. Answer is going to be 3 if n is odd. If n is odd. Check one time. If you okay with this, we can move forward. If you are okay with this, we can move forward. Edge chromatic number for Cn is equal to 2 if n is even, 3 if n is odd. Are you okay? Can I move to next? Can I move to next? Can I move to next? Yeah, let's go to one more problem. Let's go to one more problem. Let's go to one more problem. Can you see this? Can you see this one? Can you see this one? It is a K4. It is a K4. It is a K5. It is a K6. Simply remember K6. So I think everyone is 5 degree. Everyone is 5 degree. Yeah. So can you try one by one? Edge chromatic number for everyone. Can you find out? Every simple graph. One theorem is there I am saying. Every simple graph contain. One theorem is there. Every simple graph contain edge chromatic number. Edge chromatic number either D. Every simple graph contain edge chromatic number either D or MD or MD plus 1. Every simple graph contain edge chromatic number MD or MD plus 1, where MD is maximum degree. Where MD is maximum degree. Every simple graph contain edge chromatic number MD or MD plus 1. MD or MD plus 1. Every simple graph contain edge chromatic number as MD or MD plus 1. So listen, only two answers possible, either MD or MD plus 1, where MD is the maximum degree. If you want, you can go and check, right? If you want, you can go and check. Can you check here? Can you check here? What is the maximum degree? 2. What is the maximum degree? 2. So answer will be either 2 or 3. So 2k. Next one. Can you go here? What is the maximum degree? 2. Maximum degree 2. Answer is 2 or 3. So 3. Here maximum degree 2. Answer is 2 or 3. So 3. Next one. Edge chromatic number for Cn, right? That is conclusion. Okay. Next one. Come here now. K4 edge chromatic number, right? So everyone know maximum degree 3. Answer will be 3 or 4. So 3. Here also answer is maximum degree is going to be 4. Answer is 4 or 5. Check. Here answer is going to be maximum degree 5 or 6. 5 or 6. Verify. 5 or 6. Verify. Maximum degree or plus 1. Every simple graph contain edge chromatic number either MD or MD plus 1. Is it MD or MD plus 1? So can you help me now? K4, what is the answer? 3. I give an answer also, please check. Can you help me now? K5, what is the answer? I think many people are given. Please try also. If something wrong, please let me know. K5, 5. If something wrong, please let me know. Please keep properly. Right? K5 is 5. And one more thing, listen. One more thing. K6, 5. Verify properly. Verify properly. See this one. And one more thing. K7. Can you help me now? What is the answer here? K7? 6 or 7? K7 is 6 or 7. But answer is 7. So remember edge chromatic number for Kn is equal to edge chromatic number for Kn is equal to n minus 1 is equal to n minus 1. If n is even, please verify yourself, because when I am verifying it is taking lot of time. Answer is going to be n. If n is odd, please check, please take care this one, nothing there. When I am verifying manually, it is taking lot of confusion, lot of time waste. Just follow the theorem. Every simple graph contain edge chromatic number as either MD or MD plus 1, where MD is maximum degree. So I given some examples also. K4 is 3. So K4 maximum degree is 3. Answer is 3 or 4. But because of even 3. K5 answer is 4 or 5 because of odd 5. K6 answer is 5 or 6 because of even 5. K7 answer is 6 or 7 because of odd 7. Similar way, Kn n minus 1 if n is even. Kn answer is n if n is odd. That's it. Nothing there. See this? Careful everyone. Carefully everyone listen. This also listen, it's perfect. This also listen, it's perfect. Careful. Manually this topic is complex because so many edges are there. Giving color is very difficult. Manually this topic is difficult. Manually this topic is difficult. Now listen. Is it bipartite graph? Can you help me know what is the maximum degree? Can you help me know? Find out what is the maximum degree. Find what is the maximum degree. Find what is the maximum degree. Please find out maximum degree. Right. So maximum degree 4. See this one. Maximum degree 4. To this graph maximum degree 4. Everyone now. Listen everyone now. Listen everyone now. Maximum degree 4. So answer should be either 4 or 5. Answer should be either 4 or 5. But one thing. Is it bipartite graph? Complete bipartite, whatever it may be. Is it bipartite graph? Is it bipartite graph? Complete or not doesn't matter. If it is a bipartite graph, answer is always 4. Answer is always 4. Answer is always 4. Answer is actually 4 or 5. Because of it is a bipartite graph, 4 only. So, go once again here. Every bipartite graph, edge chromatic number is equal to maximum degree. If you do manually, it will be time consuming. Please verify this also. Every bipartite graph, edge chromatic number is equal to maximum degree. Every bipartite graph, edge chromatic number is maximum degree. Every bipartite graph, edge chromatic number is maximum degree. Actual answer is 4 or 5. Maximum degree you only said 4. Maximum degree you only said 4. So answer should be either 4 or 5. Right? Because of it is a bipartite 4 only. Every bipartite graph, edge chromatic number is maximum degree. If you do manually, it is a time consuming. Manually, so many edges will come. See, 3 into 4, 12 edges you have to give. It is a difficult. Manually, this topic is difficult. Manually, this topic is difficult. Please take care. Okay, fine, perfect. Manually, this topic is difficult, right? So, please remember all of them. Please remember all of them. Right? Next one. Next one. Be careful. Be careful, everyone. Be careful, everyone. See this. This also remember. This also remember. This also remember. This also remember here. So 4 manually, because so many edges are coming, so it is going to be difficult. It is a K34. This diagram everyone know K34 it is. It is K34. Let's take one more new vertex. Let's take one more new vertex. Let's take one more new vertex. Add to everyone. Add to everyone. Manually this topic is very danger. Manually this topic is very danger. Now listen. Now listen now. In this diagram, what is the maximum degree? This is the yesterday's problem. In this problem, what is the maximum degree? This is the problem. This is the problem where we stuck. This is the problem where we stuck. What is the maximum degree? Here maximum degree is 3 plus 4, 7. Someone is saying that every bipartite is simple graph. Yeah, I think, but it is the right. Every bipartite is simple graph. It's fine. That is the reason two answers are coming. Two answers are coming because of it is once again special. Every simple graph contain maximum degree or maximum degree plus 1. Because of it is a bipartite graph, it is also simple graph. Answer is maximum degree plus 1. But it is a bipartite, special one. So answer is maximum degree only. So see, now also we satisfied. Either MD or MD plus 1. Either MD or MD plus 1. But because of bipartite, MD only. Check. Right, next one. Can you come to this problem? Maximum degree is 7. Listen now, maximum degree is 7. Remember, in all the simple graph, everyone listen, in all the simple graph, bipartite graph is one model. Bipartite graph is one model. In all the simple graph, complete graph is one model. In all the simple graph, complete graph is one model. So one formula. Right? But everyone will say, every simple graph will satisfy answer as either MD or MD plus 1. Every simple graph will satisfy answer as either MD or MD plus 1. Suppose cycle graph, right? One story there. There also maximum degree or maximum degree plus 1, right? Even cycle one answer, odd cycle one answer. Even cycle will goes to this one, odd cycle will goes to this one, something like that. That is for cycle graph. But when you go to complete graph, again same. Answer is either MD or MD plus 1. Even MD. Odd MD plus 1. Something like that coming. The next one. Whenever it's a bipartite graph, always MD. Bipartite graph, always MD. They are the special cases. Bipartite graph, right? Answer is MD. Now come here now. Listen everyone now. Come here. It is not a complete graph. It is not a cycle graph. It is not a bipartite graph. It is not a bipartite graph. It is not a cycle graph. It is not a complete graph also. It is not cycle. It is not complete. It is not cycle. It is not complete. It is not bipartite also. See this one. Maximum degree 7 means answer is 7 or 8. Maximum degree 7 means answer is 7 or 8. Now can you help me now? In this graph, at least 3 people, it is not complete, it is not cycle, it is not bipartite also. In this graph, at least 3 people with the maximum degree 7. Maximum degree 7. In this graph, is not a special graph. In this graph, right, at least 3 people with maximum degree. in this graph, at least 3 people with maximum degree. With maximum degree, 1 person only. At least 3 people with maximum degree available. Let me write now. In simple graph, this note also please take care. In simple graph, if at least 3 vertices with maximum degree, then edge chromatic number is equal to, with maximum degree, then edge chromatic number is equal to maximum degree plus 1. In simple graph, if at least 3 vertices with maximum degree, then edge chromatic number is equal to maximum degree plus 1. At least 3 people with maximum degree. Can you help me now? Maximum degree 7. Here at least 3 people with maximum degree? No. That is the reason. Then answer is going to be, right? Then answer is going to be 7 only. If at least 3 people with maximum degree, then answer is 8. See this one. In simple graph, if at least 3 vertices with maximum degree, then edge chromatic number is equal to maximum degree plus 1. But here, maximum degree only 1 person there. But to satisfy this one, at least 3 people required with maximum degree. At least 3 people required with maximum degree. Other than this, nothing there. Right? In simple graph, if at least 3 vertices with maximum degree, then right, edge chromatic number is equal to maximum degree plus 1. Right? So please take care all these things. Please take care all these things. If anyone is not getting, right, go through all of them one time. First model for cycle graph. Second model for complete graph. Right? So the conclusion is every simple graph contain edge chromatic number either MD or MD plus 1. Next one, further. Bipartite graph answer is MD. Bipartite graph answer is MD. Suppose no, it is not matching any criteria. It is not matching any criteria. Simply simple graph. It is not matching any criteria. It is simply simple graph. It is simply simple graph. Then maximum degree find out at least 3 people with maximum degree. At least 3 people with maximum degree. Then answer is going to be, right, MD plus 1. Right. Now come here now. Because of everyone is okay. Because of everyone okay. Can you go to our problem? Don't confuse. Don't confuse. Go to our problem. Go to our problem. Wherever we stuck, go there. Yesterday we done it. Yeah, this one. This one. It is taken some time, but because of it is a new topic. Don't worry. Don't worry everyone. Can you help me now? K34. What is the answer? K34. Because of it is a bipartite graph. Bipartite graph. What is the answer? Maximum degree. Maximum degree. Because of it is a bipartite graph. Maximum degree. So what is the maximum degree? Because of it is a bipartite graph. What is the maximum degree? 4. Answer is 4. Maximum degree 4. Until here maximum is 4. But when you add one more vertex, it is not a bipartite graph. When you add one more vertex, it is not a bipartite graph. So maximum degree here 7. At least 3 people with the maximum degree. No. Answer is 7 only. If at least 3 people with the maximum degree, answer is 8. If at least 3 people with maximum degree, answer is 8. But 3 people not there. Maximum degree 1 person only there. Answer is 8. See, answer is always either MD or MD plus 1. Only 2 models are there. Answer is always MD or MD plus 1. Only 2 answers. There is a debate. Is it MD or MD plus 1? Kn, complete graph. Kn, n is even, md. N is not even, md plus 1. Next one, Cn, n is even, md. N is even, md. N is not even, md plus 1. Everywhere this is the debate. Next one, bipartite graph, only md. Bipartite graph, only md. Okay, these three models are not satisfying. Then find maximum degree. At least 3 people with maximum degree. Then answer md plus 1. If not md. If not md. Right? Fine. Yeah, what is the answer? Consider the binary relation. Some relation is given. Yeah, I think a lot of time is happened. So we done only one problem. That's okay. Some theory is happened. Now can you come here now? Which one of the following is true? So some relation is given. xy, xz, zx, zy. On the set xyz. Which one of the following is true? So R is symmetric. If symmetric, xy there, yz should also be there. No, R is not symmetric. R is not, so R is symmetric. R is not symmetric but anti-symmetric. Can you say what is the meaning of anti-symmetric? Anti-symmetric means xy should be there. If xy there, yx also there, then x is equal to y. That is the meaning of anti-symmetric. Anti-symmetric means if xy there and yx also there, then x is equal to y. Then x is equal to y. Right? If xy there, yx also there, then x is equal to y. That's what you want to say. That is the meaning of anti-symmetric. So can you help xy there? Listen everyone now. Xy there. So is it the meaning of anti-symmetric? Can you help what is the anti-symmetric definition? Asymmetric definition. Asymmetric definition. Asymmetric definition, anti-symmetric definition. What is the difference? What is the difference between asymmetric and anti-symmetric? If anyone is not okay, see the notes and talk. What is the difference between asymmetric and anti-symmetric? Which one having more conditions? Which one having more conditions? Asymmetric, anti-symmetric? Which one having more conditions? Asymmetric, anti-symmetric? Which one is having more conditions? So asymmetric, xy there, then yx cannot be there. xy there, then yx cannot be there. But what is the meaning of anti-symmetric? If xy there, yx also there, then x is equal to y. 1 there, 2 there, then 3 should happen. Right? Everyone, if anyone don't know, one time check. If anyone having small doubt, one time check. Now he's asking which one of the following is true. Can you help Everyone listen. xy there. Listen. xy there. I think this one. This is the case where it is fail. xz there, zx there. But x is not equal to z. Because of this, it is not anti-symmetric. But anti-symmetric. So R is not symmetric because xy there, yx not there. R is not symmetric because of this reason anti-symmetric also fail. R is neither symmetric nor anti-symmetric. Everyone know. Everyone given answer as D. If anyone not okay with this, please see the definition. Please see the definition of these two. This is the only thing which I want to convey to you. I want to convey to you, see the difference of asymmetric, anti-symmetric. So problem number 23, everyone okay. D option. What is the 24? Can you say what is the 24? Problem number 24. Problem number 24. Try this also. Right. So R be a symmetric and transitive relation on set A, then R is reflexive and symmetric. See, remember, R is symmetric and transitive. See, collect the definitions. Symmetric, transitive. Collect the definitions. Symmetric, you know, transitive also you know. Right? Collect the definition of both. Then which one is true is asking. Right? Let me check. Then R is reflexive. How R? R is reflexive. How? So can you help me? What about this one? Set A is equal to 1, 2, 3. Set A is equal to 1, 2, 3. Relation R is equal to can you help me now? 1, 1. 1, 1. Can you help me now? Is it symmetric? Yes. Is it transitive? Yes. But it is not reflexive. R is reflexive. No. R is reflexive. No. Next one. R is reflexive. No. So answer is none of these. R is symmetric and transitive relation on set A, then R is reflexive. Am I right or not? R is symmetric and transitive, then R is reflexive. So you only say if R is symmetric and transitive, then R is reflexive. Is it true? I give an example also. Can you see the example? Can you see the example? If A is equal to 1, 2, 3, R is equal to 1, 1. It is a symmetric. It is a transitive also. It is a symmetric, it is a transitive also. But where is the reflexive? Reflexive means what? For every 1, 1, 1, 2, 2, 3, 3 should be there. Then R is reflexive and hence equivalence relation. Then R is reflexive and hence partial order. How we are? So answer 4 or not? Check if I am wrong. Then R is reflexive. Reflexive means all should be there, na? Reflexive means 1, 1 should be, 2, 2 should be, 3, 3 should be. Reflexive means 1, 1 should be, 2, 2 should be, 3, 3 should be. Someone is saying number of equivalence relations. He is not asking number of equivalence relations. He is asking let R be a symmetric and transitive on set A, then R is reflexive. How can you say? How can you say that? Reflection means 1, 1 should be, 2, 2 should be, 3, 3 should be, right? Yeah. So answer is 4. Is it okay? Will you agree? Will you agree? See this one. See this one. Symmetric transitive implies reflexive. I cannot say this. Symmetric transitive implies reflexive. I cannot say this. If anyone is not agree, I will see once again. Is it fine? Are Rohit, is it fine? Diksha, is it fine? Diksha, is it fine? Right. But the combination of reflexive, symmetric, transitive is equivalent relations. True. See what he is saying? Then R is reflexive and hence equivalence relation. Let R be a symmetric and transitive relation, then R is reflexive and hence equivalence relation. Then R is reflexive and hence equivalence relation. R is reflexive and hence partial order. Right, it's okay. Can we move to next? Arey J, is it okay? Arey J, is it okay? Can we move to next? Suppose if the question is let R is symmetric and transitive on set A, if R is right, if R is reflexive and hence equivalence relation, right? Some changes are there, then answer may be A, something like that, right? I cannot give guarantee. He simply said one thing, R is symmetric and transitive on set A. If R is reflexive also, then right, hence equivalence relation, something like that I can understand. Right, fine. Remember, listen, just no need to misunderstand the problem. These two true doesn't mean that. It is reflexive. Just remember, right? Indirectly, directly, I want to say these two are true. It doesn't mean that. These two are true. It doesn't mean that it is reflexive. R is symmetric and transitive, then R is reflexive and hence equivalence relation. So I cannot comment this. If equivalence, then these three should be satisfied. So see this one, see everyone now. Reflexive, symmetric, transitive, then equivalence relation. Next one, equivalence relation, these three. This is true. Reflexive, symmetric, transitive, then equivalence relation. Equivalence relation means these three should be there. But symmetric, transitive, satisfied. I cannot say reflexive. Symmetric transitive satisfied, I cannot say reflexive. Right? Yeah, go to the next problem. Yeah, so see the answer. Let x is equal to 2, 3, 6, 12, 24. Let less than or equal to be the partial order defined by x less than or equal to y if x divides y. Number of edges in the Hasse diagram. Number of edges in the Hasse diagram. What is the answer? Let less than or equal to be partial order defined by x less than or equal to y if x divides y. Then the number of edges in the Hasse diagram of x less than or equal to is. So what is the answer? I think Hasse diagram is asking. So x divides y. So 2 divides, right? 2 first 2. Right? Next one. I think 2 is not dividing 3. So 3 also in the same level. But 6 divides both. 2 divides 6 also. 3 divides 6 also. I think 12. So it should be here. 24. It should be here. Always keep the new element at the new level. Keep the new element in the new level. Suppose suppose it is not working, then try to bring next level. See this one. First I took 2. Next I took 3. I kept in the new level, but it is not. Then I kept in the same level. Next I took 6. I kept in the new level. Yes, it is working. I took next 12. It is working. Next I took 24. It is working. Can you see how many edges are there? The number of edges in the Hasse diagram is 2 plus 2, 4. So B. Someone is saying that if symmetry can transitive, then always it is irreflexive. How can you say this? If symmetry can transitive, then always irreflexive. How, yaar? See this one. See everyone. A is equal to 1, 2, 3. A is equal to 1, 2, 3. See the relation are 1, 1, 2, 2, 3, 3. It is symmetric also. It is a symmetric also, transitive also. It is a symmetric also, transitive also. You cannot say it's a irreflexive. Oh, you said irreflexive. Yeah, I think, let me see. J, I think your answer may be right. Let me verify once again. R is equal to 1, 1, 2, 2, 3, 3. You are saying that symmetric also and transitive also. Symmetric and transitive. Then it is irreflexive means what? What is the meaning of irreflexive? One pair of XX also cannot be there. One pair of XX also cannot be there. One pair of XX also cannot be there. Let me try this. Everyone listen. Let me try. If A is equal to 1, 2, 3, relation R is equal to empty set. Can you help me now? Is empty set symmetric? Yes. Is empty set is a transitive? Yes. But what about this one? Is it irreflexive? Is it irreflexive? Yes, it is irreflexive. It is irreflexive. Yeah, can you see this problem? Can you see this problem? Is it irreflexive? It is a symmetric, it is a transitive, it is irreflexive. It is a symmetric, it is a transitive, is it irreflexive? Arey J, it is a symmetric, it is a transitive, it is a irreflexive. No, na? It is no. Symmetric transitive doesn't mean that irreflexive. Symmetric transitive doesn't mean that irreflexive. Don't bring unnecessary conclusions. Right? See this one. This may be true. See this one. It is symmetric. It is transitive. Symmetric and transitive. But it is irreflexive. Yes, because XX pair not there. Irreflexive. See, but here if you observe XX pair there, it is not irreflexive. It is a reflexive. So J, are you okay now? J, are you okay now? Empty set is irreflexive. Yes, because XX pair not there. XX pair not there means irreflexive. All XX pairs should be there, reflexive. All XX pairs there, all XX pairs only there. All XX pairs only there, symmetric also. Reflexive also, transitive also. Only XX pairs, all XX pairs. Only all XX pairs, symmetric, reflexive, transitive. If nothing there, symmetric. If nothing there, transitive. If nothing there, irreflexive. If nothing there, not reflexive. Yeah, can we move to next? Diksha, can we move to next? Pi set is not reflexive. Yes. Pi means there is no XX pair. Pi means there is no XX pair. So it is not reflexive. Yeah, go to the next. Yeah, try this. Let R be a non-empty relation on a collection of sets defined as A or B if and only if A intersection B is equal to pi. Then pick R is reflexive, R is symmetric and not transitive, R is an equivalence relation, R is not. So if anyone is not getting these relations, please see the definitions once. If anyone is not getting these, please see definitions once. Please see definitions once. And one more thing is edge coloring, right? Edge chromatic number formulas only important, because manually you cannot do, because more edges. We tried also. Edge coloring or edge chromatic number, right? Manually you cannot check because many edges, right? Please follow the formulas. Tomorrow I will give some problems also. What is the edge chromatic number? Right? You can try. Right? First, please go through it. Whatever I covered, please go through it. Tomorrow I will ask some more problems. Now, can you say what is the answer of this? Yeah, what is the answer for this? Yeah, can you see this? Everyone listen. Everyone listen. It is the set S1. It is the set S2. S1 to S2 relation is there. Listen, S1 to S2 relation is there. If S1 set contain AB, if S1 set contain AB, if S2 set contains CD, right? Intersection C. Here AB, S1 contain AB elements, S2 set contains CD elements, S1 set contain AB elements, S2 set contains CD element. If intersection is pi, then there is a relation. Then these two are related. Two sets are related if intersection is pi. If intersection is pi. Two sets are related if intersection is pi. Can you help me now? I want answer from you. I want answer from you. AB related to CD or not? Please let me know. AB related to CD or not? Please let me know. AB related to CD or not? Set AB related to set CD or not? Set AB related to set CD or not? Yes? Yes, now see the answer. Set AB related to set AB. Set AB related to set AB? No. That means, right? That means reflection gone. It is not a reflexive relation. Set AB related to set AB? No. Because intersection is not pi. Right? Someone is saying confusing. Yeah, you can write this. Listen everyone now. Set 1 to related to set 3 4. Yes, because intersection is pi. Set 1 to related to set 1 to. Same thing mapping. No. Same thing mapping. No. Now see the interesting answer. See the interesting answer. 1 2 map to 3 4. In the similar way, 3 4 map to 1 2. Can anyone help you now? Is this relation symmetric? Is this relation symmetric? AB there, BA also there. Is it symmetric? Two people related if no common element. Two people related if no common element. It is a symmetric. It is a symmetric. It is a symmetric. Now can you see this? Now can you see this? Now can you see? Everyone listen. Everyone listen. 1 2 related to 3 4. 1 2 related to 3 4. That is the one thing. Next one. 3 4 related to 5 6. 1 2 related to 3 4. 3 4 related to 5 6. Then I can say 1 2 related to 5 6. Is it right or wrong? 1 2 related to 3 4 no common. 3 4 related to 5 6 no common. Then 1 2 related to 5 6. See, if two people are related, if intersection is pi, two sets are related if intersection is pi. But Diksha, can you see this? Diksha, can you see this? Diksha, can you see this one? 1 2 related to 3 4. Listen, 1 2 related to 3 4. That is the relation already there. Next one, 3, 4 related to 3, 4 related to 3, 4 related to, careful, 3, 4 related to 1, 5. 3, 4 related to 1, 5. But these two are not related because common element is 1, 2, 1, 2 related to 1, 5. 1, 5. It is wrong because 1 is common. Because 1 is common. Because 1 is common. So trans 2 may not satisfy. Trans 2 may not satisfy. Reflection cannot satisfy, but symmetric will satisfy. Trans 2 will not satisfy. Are you getting? But trans 2 will not satisfy. A related to B, B related to C, then A related to C. Sometimes may not be. 1, 2, 3, 4 relation. 3, 4, 1, 5 relation. But 1, 2, 1, 5 no relation because 1 is common. Because 1 is common. It is not pi. It is not pi. 1 is common. So, can you say final conclusion? Can you say final conclusion? R is reflexive and transitive. No. R is symmetric, not transitive. Yes. R is equivalence relation. No. R is not reflexive and not symmetric. No, it is symmetric. It is symmetric. Yeah. So let me ask you one small line. Last question I want to ask you. Listen. Last question I want to ask you. Listen. Last question I want to ask you. Two people related. Everyone listen. Everyone listen. Everyone. Can you listen my line? Can you listen my line so that you will get the. See. If and only if. See this one. If and only if. What is the meaning? If two people related, they should be there in the relation. If two people related, they should be there in the relation. What is the meaning? Listen, what is the meaning? Between two people, intersection pi, they should be there in the relation. Can you see this one? 1 and 2, intersection 3 and 4, pi, they are related. You take any pair, 1, 2, intersection 3, 4, it is a pi. So they are related. They are related means in the reverse also possible. If you take 3, 4, intersection 1, 2, possible. So like this, 1, 2, 3, 4 is the one set. Because of every pair is available. 3, 4, 1, 2 also available. Every pair which will satisfy that condition available. Every pair which will satisfy that condition is available. Every pair. Every pair which will satisfy that condition available. R is symmetric and not transitive. One pair also you cannot miss. Every pair which will satisfy this condition should be there. One pair also cannot miss. It is if and only if both the sides, see, A or B related. If and only if A intersection B is pi, between two people intersection pi, they will be related. Between two people intersection pi, they will be related. 1, 2, 3, 4 intersection pi. 3, 4, 1, 2 intersection pi. If I take left side 1, right side 1, intersection is not pi, you cannot take. Right, is it okay now? Now okay. Now okay. Every pair should be there. See this one. Intersection is pi between two sets. It should be there in the relation. Now, can you help me one small line? Can you help me one small line? 1, 2, listen, 1, 2, 1, 5 is intersection pi. 1, 2, 1, 5 is intersection pi. 1, 2, 1, 5 is intersection pi. 1, 2, 1, 5. 1, 2, 1, 5 intersection pi. 1, 2, 1, 5 intersection pi. No. No means in the relation they cannot be. Intersection pi, no. Intersection not pi. In the relation they cannot be. Next one. 1, 2, 1, 2, 3, 4 is intersection pi. In the relation, this should be there. Next one. 3, 4, 1, 2. 3, 4, 1, 2 intersection pi. In the relation it should be. Between two people, if intersection is pi, they should be there in the relation. In a lattice defined by the Hasse diagram given below, how many complement does the element E have? Everyone know. Listen, everyone know. O per diagram. See this one. O per person, upper bound. Bottom person, lower bound. To this lattice, upper bound is A, lower bound is F. Now he is asking E complement. Can you help me now? E, R, G. What is the answer? LUB. E and G, where they are meeting upper. E and G, where they are meeting upper. A, upper bound. Next one, E and G meeting below where? F, lower bound. So E complement is G. Right? In the similar way, E and C meeting upper where? A. E and C meeting below where? F. Again, E complement is C. Next one, E and D meeting upper where? A. E and D meeting niche where? F. So E complement is F also. So E having 3 complements. Am I right? For two people, LUB is upper bound. GLB is lower bound. Then I can say those two are complement to each other. It is a D. Yeah, it is a D. So finally, E complement is going to be G also, C also, D also. For two people, LUB is upper bound, GLB is lower bound. Then I can say those two are complement to each other. So 3 complements are there. Is it okay? Everyone know how to find out complement. In the diagram, whoever is there, upper. First of all, it should be a lattice. In the lattice, upper person is upper bound. Niche person is lower bound. In the lattice, first of all, it should be a lattice. In the lattice, upper person is upper bound. Niche person is lower bound. Between two people, LUB coming upper bound. Between two people, GLB coming lower bound. Then those two are complement to each other. Now, if you want, you can verify these two people. E, R, B, right? Edge there means upper person is, right, LUB. Edge there means niche person, E is the lower bound. So upper bound, lower bound not coming. They are not complement to each other. Edge there means one person is, right, upper person is the LUB, niche person is the GLB. They are not complement to each other. Between two people, edge there. One corner is upper bound, one corner is lower bound. You are not getting upper bound, lower bound. You are getting, right, one of the person is upper bound, one of the person is lower bound. They are not complement to each other. You know very well. You know very well. See, this is the rank improvement course. Right? I am not able to teach everything. The reason why I spend more time on the edge cover is we didn't cover. We didn't cover it, so I tried to cover here. I tried to cover here. I tried to cover here. Yeah, V is a R operator. Right? V is R operator, which is also called LUB, least upper bound. LUB, least upper bound. Intersection means end operator, which is also called GLB, greatest lower bound. Right, go to the next one. Yeah, I think this one in the notes also I said to you, the number of equivalence relations on the set 1, 2, 3, 4 is equal to, I think B, right? Bell number 4 is equal to 15. Right? Bell number 4 is equal to 15. Bell number. In the class notes I said. In the class notes I said it's a bell number. Number of equivalence relations on the set 1, 2, 3, 4 is equal to bell number B4. Just Google it out, you will get. Just Google it out, you will get bell number B4. Right? Yeah, that's what I'm saying. Bell number. Just Google it out, you will get how to find out bell number. For n, right? B4, how to calculate bell number 4. Right? Bell number 4. Which is called B4. Which is 15. Yeah, you try. If not, tomorrow I will give. Tomorrow I will try to give that. First you try. If not, tomorrow I will give. Let's go to next. Can you say what is the answer of this? So what is the answer? Yeah, let's see. Let's see the example. One example you see. See the one example. See one example. R1 is equal to set A is 1, 2, 3. Set A is 1, 2, 3. R1 is equal to, when you say it is a equivalence relation, it should be symmetric. It should be symmetric. Next. It should be symmetric. It should be transitive. It should be reflexive. Am I right? Equivalence relation means symmetric, transitive, and reflexive. RST. In the class we are already done. Equivalence relation means RST. Reflexive, symmetric, transitive. Am I right? Now see this. Now see this one. A is equal to 1, 2, 3. R1, relation R1 is equal to, first of all, it should be a equivalence relation. First of all, it should be a equivalence relation. Let's see. When you say equivalence relation, first of all, it is a reflexive. 1, 1, 2, 2, 3, 3 should be there. 1, 1, 2, 2, 3, 3 should be there. First of all, it should be a reflexive. I think this is a common element. These are common elements. These are common elements. Okay, fine. Now listen. These are common elements. Careful everyone. Reflexive, transitive, and one more thing is symmetric. Symmetric. Now see. See everyone. 1, 2, reverse is 2, 1. 1, 2, reverse is 2, 1. So, if you observe clearly this one, reflection already there. Symmetric also there because 1, 1 reverse is 1, 1. 2, 2 reverse is 2, 2. 1, 2 reverse 2, 1. 2, 1 reverse is 1, 2. So, reflection there, symmetric is there. See the transitive. 1, 2. 2, 1. So, 1, 1 already there. 2, 1. 2, 1. Starting with 1. 2, 1, 1, 2. I think 1, 1 cancel, 2, 2 already there. So for everything there, it is a transitive also. Please check properly class notes. Please check properly class notes. 1, 1, 2, 2, 3, 3 here also. Let's see this. Can you everyone listen? Can everyone listen? Can everyone listen? One, 3, 3, 2. 1, 3, 3, 2. Please check. Is it reflexive? Is it symmetric? One, 3, 3, 2. 3, 3 cancel. 1, 2. 3, 2. 3, 2. Yeah, it's perfect. 1, 2. Right. Yeah. Now see. Can you help me now? Can you do intersection? What is the intersection of these two? What is the intersection of these two? Can you help me now? What is the intersection of these two? When you do intersection, compulsory reflexive people will come. When you do intersection, compulsory reflexive people will come. Anything else? Anything else? Someone is saying 2, 1 required. Let's check 2, 1. How 2, 1? Someone is saying, right, in the R2, 2, 1 required. How? See, 1, 3, 3, 2. 1, 3, 3, 2. Oh, so 1, 2 reverse is 2, 1. Of course, right? Transitive, right? Symmetric also. 1, 3 reverse 3, 2. 1, 3, 3, 2. So 1, 2. Transitive. So 1, 2 reverse is 2, 1. Now if you do the intersection, all common people came and 1, 2, 2, 1 also came. 1, 2, 2, 1 also came. Common people. 1, 2, 2, 1 also came. Fine. So remember everyone, you plan whatever way you want. Intersection of two reflexive relations is always reflexive. Intersection of two reflexive relations is intersection of two equivalence relations always equivalence. Remember this. I given one example also. You take any example, not only this. You take any example, it is always true. You take any example, it is always true. So let me give one more example so that you will get the full clarity. So this is 2, 3. This is 2, 3, 3, 2. 2, 3 reverse is 3, 2. One more example I am giving. 2, 3 reverse is 3, 2. 3, 3 cancel 2, 2. 3, 2, 2, 2 cancel 3, 3. Next one. 1, 2 reverse is 2, 1. Both are cancelled. So 1, 1. So that is, if you do the intersection, see this one. If you do intersection, common people are these only. 2, 3, 3, 2 not common. Right? Intersection. This is the intersection story. This is the intersection story. Can you see the union? Can you see the union? Everyone listen. Union means all people. Union means all people. Let me do union. I am doing union. This is the union. All people will come. Let's see the all people. 1, 1, 2, 2 guarantee will come. 3, 3 also guarantee will come. Right? Be careful. Next one. 1, 2, 2, 1 also will come. No problem. Next one. Right? 2, 3 will come. 3, 2 also will come. All people will come. Right? But see the problem. See this one. But see the problem. Everyone listen. But see the problem. 1, 2, 2, 1. Yeah. Is there any element missing? Can you check? Is there any element missing? Is there any element missing? After doing union, is it equivalence relation or not? Please let me know. See this one. 1, 2, 1, 2, 2, 3. Everyone listen. Everyone listen. I made one example also. See this one. 1, 2, 2, 3. According to trans 2, 1, 2, 2, 3 becomes 1, 3. 1, 3 not available. 1, 3 not available. 1, 3 not available. 1, 2, 2, 3. Trans 2 property 1, 3 not available. So final conclusion. Listen. Final conclusion. Equivalence relation 1 intersection equivalence relation 2. You will get the equivalence relation 3. Confirm. Next one. Equivalence relation 1 union equivalence relation 2. No guarantee. No guarantee. No guarantee. Please careful. No guarantee. So this one can you remember? Intersection of two equivalence relations are equivalence. Union no guarantee. This is the example. Please take care. Counter example. One counter example is enough. Union will fail because many combinations are coming. Union fail because many combinations are coming. Union fail because many combinations are coming. Intersection pass because subset only will come. When you do intersection, whatever equivalence relations are there, subset only coming. An important thing is common point is reflection will come. Reflection common in both. Reflection common in both. Other people common elements are coming. So can you remember this? Intersection of two equivalence relation is always equivalence relation. Union of two equivalence relations no guarantee. No guarantee. One example also I given, you take care. R1, R2. Please do properly R1, R2. Take one R1. It need not be this one. You take anything. Take one R1, but it should be an equivalence relation. Take R2, it should be an equivalence relation. Then do intersection. Always you will get the equivalence relation. Union sometimes pass, sometimes fail. Union sometimes pass, sometimes fail. So no guarantee. Sometimes pass, sometimes fail. No guarantee. Right? Now go to the question number 30. Now go to the question number 30. The binary relation R is equal to 1, 1, 2, 1, 2, 2, 2, 3, 3, 4. Something like that is given. Then what is this relation is? Then R is. Yeah, check now. Please all of them one time practice. Nothing there. See, to you also difficult, to me also. See, if I don't do before, I will stuck. Those people who don't do practice, right, you will stuck. I didn't done any practice on the edge covering, I stuck. If you don't do practice, you will also stuck. See, no problem will spare anyone. If you don't do practice, you will stuck in the exam. If you do before exam, you don't stuck in the exam. No problem will spare anyone. No problem will spare anyone. It is not Reddy sir, it is not Piyush, it is not Jay, it is not Gaurav, it is not Diksha. No problem will spare anyone. If you do before, in the exam it will become easy. If you don't do, in the exam you will stuck. The binary relation, some relation is given, then the relation R is it reflexive? 1, 1, 2, 2, 3, 3, 4, 4 there? No. 1, 1 is there, 2, 2 there, 3, 3 also there, 4, 4 not there. Reflection gone. Reflection gone. Next one. Is it symmetric? 2, 1 reverse 1, 2. 2, 1 reverse 1, 2. No. No. Reflection gone. Is it irreflexive? 1, 1 is there. 1, 1 is there. Irreflexive also gone. Irreflexive also gone. Neither reflexive nor irreflexive but transitive. This is the only option left out. See, some are easy, some are tough. Some are easy, some are tough. See, by seeing one problem, you no need to discourage. By seeing one problem, you no need to discourage. Right? Anything is not okay. Revise again. Anything is not okay. Revise again. Anything is not okay. Revise again. See, this is the example. This is the example. One relation which is not reflexive, which is not irreflexive also. Neither reflexive nor irreflexive. Neither reflexive nor irreflexive. This is the example. This is the example. Yeah. Can you help me one small question? Can you help me one small question? Please give answer. Please give answer. Can you help me one small question? Can you help me one small question? Yeah. Someone is saying how transitive. Please check. So forget about all the reflexive things. Remaining things you check. Because reflexive anyhow satisfied. Remaining things you verify. 2, 1, 2, 1, starting with 1, no use. Next one. 2, 2, next one. 2, 3, starting with 3. 2, 3, 2, 3, starting with 3. 3, 1, 2, 3, 3, 1. So 2, 1 already there. 2, 3, starting with 3, this one. Starting with 3, this one. 2, 3, 3, 1. So 2, 1 already there. Next one. 2, 3, 3, 2. 3, 3 cancel. So 2, 2 already there. Next one. 2, 3 starting with 3. 2, 3, 3, 3. So 2, 3. 3, 3 cancel. 2, 3 already there. 2, 3, 3, 4. 3, 3 cancel. 2, 4 already there. So this is successfully completed with all. Let's go to similar way 2, 4. 2, 4 starting with 4. Anyone? No. It is already done. Next one. 3, 1, 3, 1, starting with 1, anyone, only first person. 3, 1, 1, 1, 3, 1, already there. Next one, 3, 2, starting with 2, anyone. 3, 2, 2, 1, 3, 1. See correctly now. It may be looking like fail. See this one. 3, 2, 2, 1, 2, 2 cancel. 3, 1, already there. Next one. 3, 2, starting with 2. 3, 2, 2, 3. 2, 2 cancel. So 3, 3, already there. So like that you have to check. 3, 4 starting with 4, no 1. So verify. Sir, his function is an important topic in DM from exams point of view. Read one time class notes. Read one time class notes. If you are unlucky, whatever you left out, those only will come. If you are unlucky, that only will come. Can you help me now? Listen everyone now. Is this graph contain even degree or odd degree? Even degree cycle or odd degree cycle? This one, odd degree cycle or even degree cycle? Even cycle or odd cycle? Even cycle or odd cycle? This graph contain even cycle or odd cycle? This graph contain even cycle or odd cycle? No odd cycle. See, no odd cycle. Remember, a graph which don't have odd cycle is a bipartite graph. Is a bipartite graph. Can I help you now? Bipartite graph. What is the chromatic number? See this one. Someone is saying that odd cycle. I am not asking degree. Cycle I am asking. Even cycle or odd cycle? Odd cycle. See, no odd cycle means it is a bipartite graph. Can I say bipartite graph chromatic number? Chromatic number means vertex color. Chromatic number means vertex color. Chromatic number means vertex color. What is the answer? 2. Bipartite graph chromatic number. Chromatic means vertex color. 2. Next one, can you help me now? Bipartite graph, edge coloring, edge chromatic number. What is the answer? Everyone know edge chromatic number. Just to find out maximum degree. What is the maximum degree? Edge chromatic number. Find out the maximum degree. What is the maximum degree? Maximum degree how much? 3. Maximum degree is 3. So answer is 3 or 4. Maximum degree is 3. Then answer is 3 or 4. Can you help me now? 3 or 4? Okay. Is it bipartite? 3 or 4? Okay. Is it bipartite graph? 3 or 4? Edge chromatic number 3 or 4? What is the answer? 3. We have only two answers, 3 or 4. Bipartite graph 3. Bipartite graph 3. Edge chromatic number, answer is maximum degree or maximum degree plus 1. Only 2 answers. 3 or 4. But bipartite graph 3. Bipartite graph 3. Right? Please take care. So I done until 30. For 12 subjects of GATE examination, every subject is approximately 200 questions to 300 questions. 300 quality questions were designed. 12 subjects, every subject 200 to 300 quality questions were designed. Approximately 2400 questions to 3600 questions. These many quality questions were designed with video solutions. Mostly in GATE examination, all questions will come from these only. 12 subjects, every subject 200 to 300 questions. Our team is all IIT experts. Myself, as I mentioned to you, 14 years. Most of my students are they're in IIT. Most of my students are there in MNCs, big MNCs. Most of my students are top 100 rankers, top 10 rankers, top 50 rankers. If you solve all these questions, I'm very sure your rank will improve by at least 10 times. Through experience, I'm saying mostly questions will come from these questions only. Don't miss at any cost. So for if you want to subscribe for this course name is called as a rank improvement course. Rank improvement course for CS, rank improvement course for DA, Right? For admissions, you can WhatsApp me to this particular number, or you can directly go to exampreptool.com, exampreptool.com. You can subscribe from there also. It is really useful to you. Don't miss at any cost. This is right. Utilize the last 2 months quality time in the quality way. Right? I hope right, you will get a lot of benefit from this. Right? All the best.